In this video, we're going to talk about some aerodynamics. If you're not familiar, I'm training in a Cessna 172M, and it comes with several different control surfaces, and as part of your oral exam for, specifically I'm studying for the private pilot license, and so being able to explain like what are flaps actually used for, and what's happening in a stall, things of that nature, which definitely comes up based on what I've seen in the mock videos and in the study material. I thought it was valuable to have a visual model for what's actually going on in the airframe in these conditions. So you'll see here I've got like a poorly drawn airplane and a turn coordinator, and then some information about what's actually happening when we apply control inputs, which is any of your steering left and right, or back pressure, or anything like that you're applying, rudder pedals, etc. And so I thought it would be valuable with each input to talk through, and then we also have a whole section on left turning forces that are applied at different phases of flight, but mostly by the engine. And so we'll just kind of go through each of these inputs one by one and talk about slips and slides and all the fun stuff that comes with uncoordinated inputs or coordinated inputs. So starting, I guess, left to right, you can see we've got ailerons here, and so we can apply some aileron input. So this is turning the yoke or the steering wheel of the airplane left or right. Turning it left will lower the left aileron and raise the right one. I might have said that backwards, but applying aileron input. So in this case, we'll go left, and so that's going to raise the left aileron and lower the right one. And you can see that without applying any rudder input, we go into what's called a skid. We're uncoordinated, and the center of gravity is shifted to the left. So that's going to increase your parasitic drag on the airframe, and can actually lead to certain types of stalls. So the correction would be you want to step on the ball, as they say. So the ball is slightly to the left, so we're going to apply some left rudder, and we're coordinated. So this is how a normal healthy turn would work. There are conditions where you might want to be uncoordinated. That's kind of more advanced stuff, like slip descents or slip forward, things like that. We'll get into that later. And so that's your aileron, and if you take away your aileron input, put that at 0, it's not necessarily uncoordinated to go to apply rudder pressure. Like if you're just making minor course corrections, like if you're on a towered landing and need to stay on heading and you don't have autopilot, this would be the way to go about it. So that's rudder. That's going to be increasing the yaw of the plane, sort of the rotational forces. And so that's sort of part of a turn, and you would apply some aileron control input to keep it coordinated if you needed to make a turn in that direction or adjust for the wind, things like that. We'll go back to 0 here, and both. And then if you need to go up and down, that's where your elevator comes in. So when you pull back or push forward on the yoke or the steering wheel, as I said earlier, that on the tail raises the elevators that control the pitch of the airplane. So you pull back on the yoke to get nose up pitch, and then you push. In most cases, you're pushing down you're pushing the control yoke in to get nose down pitch. And so that's yaw and pitch, and we can reset that. And there's also rotation, or roll, but that's a little bit different. You can achieve roll through your aileron inputs, and that actually rolls the plane around, and can lead to a spin if you're nearing a stall, and a roll will actually stall one wing more than the other and cause the plane to spin, and that's obviously to be avoided. The other control input to talk through here is flaps. I think a very common question on the oral exam is, what are flaps even for? I think a default answer that a lot of aspiring pilots come up with is that it slows the plane down, which is a byproduct of what they do. They actually increase the camber of the wing, which does two things: increases the lift coefficient and increases the drag, the parasitic drag created by the airframe, and that has the result of slowing you down. That's not really the purpose. The main purpose of the flaps is to allow you to descend without accelerating. So normally, if you would, without flaps, apply nose down pitch, gravity would accelerate you. You would pick up airspeed, and that, in cases like where you're landing, where you have a set target speed, in the 172, it's 65 knots that you're aiming for when you're landing in most conditions. So you want to be able to descend without accelerating. So it's not that you're necessarily using them to slow down, it's that you're using it to control your airspeed. And you're doing that by increasing lift and increasing drag. And so you can go full 30 here, and some planes have more, some planes have less, some planes don't have flaps at all, and then in that case you would actually be using more of a forward slip to achieve the same effect. It doesn't increase the camber, but it does increase the lift and the drag, so that you can descend without accelerating. That's sort of a crash course, pun intended, in some aerodynamics that might come up during your oral exam. And continuing on to the left turning forces, this does come up, and set some power here so we can see it better. So the things to know about left turning forces are that there are, in fact, 4 of them that affect, basically, they drive a left turning effect on the plane, and as stated here, you can correct all of them with the right rudder. But I think it's important to understand what each of them are and how they affect the performance of the aircraft. So the torque effect is, as stated, Newton's third law. The rotation of the engine itself, of the crankshaft and the propeller, rotate clockwise, creating a left rotational force. Pretty straightforward, cause and effect. I think that one is pretty, like, when you say torque, like, people kind of understand that. More complicated is the P factor at a positive AOA. Like when you're rolling down the runway, the P factor is going to be moving the plane to the left while you're trying to go down straight down the extended center line. And so you can see at a higher angle of attack, which is the difference between the chord line of the wing, specifically the sort of invisible line from the front to the back of the plane's wing, and the angle of wind, or the wind angle coming at the wing. And so that's P factor, and the correction again is just right rudder. Slipstream is something that happens while you're in flight at speed, so high RPM, low airspeed. The propeller creates a corkscrew of air that actually rotates the aircraft around. And again, right rudder is the correction. And then gyroscopic precession, I think, is the more complicated sounding one, but it's just that the spinning propeller itself, it acts as creates gyroscopic force that makes the aircraft want to rotate. And the nose yaws left, pretty straightforward. And as just like the other ones, and like I said before, it's a right rudder correction. If you have any questions about the aerodynamics prep that I'm doing, or just want to commiserate about all the stuff you didn't know you had to learn for the PPE oral exam, shoot me a message or post a comment. Thank you.